Hello science enthusiasts! Welcome to Bang with Science, the channel where we unravel the mysteries of the universe in a fun and engaging way. We're all about exploring the wonders of the cosmos, from the tiniest particles to the vast expanses of the universe. Here at Bang with Science, we believe in making science accessible to everyone, breaking down complex theories into bite-sized, digestible information that's both intriguing and enjoyable. Our mission is to spark your curiosity, ignite your imagination, and fuel your passion for learning. We delve into the mind-boggling world of quantum physics, a realm where particles can exist in two places at once, where they can be both waves and particles, and where observing a particle can actually change its state. So, buckle up, folks. You're in for a wild ride. Today, prepare to dive into the fascinating world of quantum physics. Quantum physics sounds intimidating, right? But fear not, we're here to break it down for you. Let's start by tackling the basics. At the heart of quantum physics is the idea that particles can also behave like waves. This is a mind-bending concept known as wave-particle duality. Imagine a particle, like an electron. We tend to think of it as a tiny ball zipping around. But in the quantum realm, this electron can also behave like a wave, spreading out and occupying multiple places at once. Weird, right? But it gets even stranger. Particles in the quantum world aren't just in one place or another. They can be in a superposition of states. This means they can be in multiple places at once until they are observed or measured. It's like your favorite superhero being in two places at once, saving the day, until someone shines a spotlight on them. Then, there's quantum entanglement. This is the phenomenon where particles become linked, and the state of one instantly affects the other, no matter how far apart they are. It's as if they have some sort of secret, super-fast communication channel, faster than the speed of light. And let's not forget about the uncertainty principle. This is the idea that you can never know both the position and momentum of a particle with absolute certainty. The more precisely you know one, the less precisely you can know the other. It's like trying to catch a slippery eel. The harder you try to pin it down, the faster it slips away. Quantum physics also introduces the concept of quantum fields, which are the fundamental building blocks of the universe. They are everywhere, filling every corner of the universe. Particles are just excitations or ripples in these fields. So you see, quantum physics is not as scary as it sounds. It's a fascinating world of particles behaving like waves, superpositions, entanglements, uncertainty, and fields. It's like stepping into a science fiction novel. But this is our reality, happening all around us, all the time. Ever heard of the double slit experiment? It's where the magic of quantum physics truly shines. Welcome to the world of the double slit experiment, a cornerstone demonstration of the wave-particle duality. This duality is a fundamental concept in quantum physics, implying that all particles also exhibit wave-like properties. But what does this really mean? Let's delve deeper. Imagine a wall with two slits and behind it, a screen. Now, if we throw marbles at this wall, we'd expect them to pass through the slits and hit the screen, creating two distinct bands corresponding to the slits. Simple, right? But let's swap those marbles with electrons or photons, particles that abide by quantum rules. If we fire them one at a time, logic dictates that they should behave just like the marbles, creating two bands on the screen. However, that's not what happens. Instead, an interference pattern of alternating light and dark bands appears on the screen, as if the particles went through both slits simultaneously and interfered with themselves. This is a characteristic behavior of waves, not particles. Now, here's where it gets even stranger. If we try to observe which slit the particle goes through, the interference pattern vanishes and we're back to two bands on the screen. It's as though the particles know they're being watched and decide to behave like particles again. This is known as the observer effect. So, what can we glean from this? The double slit experiment shows us that particles can behave like waves when not observed, but act like particles when observed. This wave-particle duality is one of the most fascinating and mind-boggling aspects of quantum physics, defying our everyday understanding of the world. Mind-blowing, isn't it? That's the beauty of quantum physics. Now, let's journey back in time to witness the birth and evolution of quantum physics. Let's rewind to the early 20th century. The world of physics was in turmoil. The classical laws of physics, which had worked so well for centuries, were starting to crack under the weight of new discoveries. Enter quantum physics, a bold new theory that dared to challenge these classical laws. The inception of quantum physics can be traced back to Max Planck's black body radiation experiment in 1900. Planck, in an attempt to solve the ultraviolet catastrophe, proposed that energy was quantized. This meant that energy could only exist in discrete amounts, like steps on a staircase, rather than a smooth, continuous slope. Then, in 1905, Albert Einstein, a name synonymous with genius, proposed the idea of light quanta, or photons, in his explanation of the photoelectric effect. These ideas sparked a revolution and laid the groundwork for a new branch of physics. The story of quantum physics is dotted with numerous groundbreaking theories and experiments. In the 1920s, the Danish physicist Niels Bohr proposed his atomic model, which introduced the concept of quantum jumps. Around the same time, Werner Heisenberg and Erwin Schrödinger developed the matrix mechanics and wave mechanics respectively, laying the foundation of quantum mechanics. Quantum physics radically transformed our understanding of the universe. It introduced concepts that seemed almost fantastical, like superposition, where particles can exist in multiple states simultaneously, and entanglement, where particles can be instantly connected, regardless of their distance apart. Fast forward to the present day. Quantum physics is now at the forefront of cutting-edge technology. It's the driving force behind quantum computing, quantum cryptography, and quantum teleportation, which are set to revolutionize our world. In a span of just over a century, quantum physics has journeyed from a fledgling theory to a fundamental pillar of modern science. It has challenged our perceptions, questioned our realities, and reshaped our understanding of the universe. Quantum physics, indeed, has come a long way. Quantum physics, though fascinating, does come with its set of challenges. It's like a dense forest of paradoxes and problems that scientists have been trying to navigate for over a century. One of the most intriguing challenges is the paradox known as Schrödinger's cat. This thought experiment presents a scenario where a cat in a box could be both alive and dead at the same time, until observed. This paradox originates from the principle of superposition, which states that a particle can exist in all its theoretically possible states at once. But can this really apply to the macroscopic world we live in? Then there's the uncertainty principle, proposed by Werner Heisenberg. It says that it's impossible to know both the position and momentum of a particle with absolute certainty. The more precisely one property is known, the less precisely the other can be known. This principle challenges the very basis of classical physics and has left even the brightest minds scratching their heads. And let's not forget about quantum entanglement, another bizarre and counterintuitive aspect of quantum physics. This phenomenon allows particles to be interconnected in such a way that the state of one can instantaneously affect the state of the other, no matter the distance between them. This defies our everyday understanding of reality and has often been termed as spooky action at a distance by Albert Einstein. Despite these challenges, scientists are not deterred. They're constantly striving to understand these paradoxes and devise ways to utilize the unique properties of quantum physics. Efforts are being made to develop technologies like quantum computers and quantum encryption, which could revolutionize our world. However, the journey is far from over. The more we delve into the quantum realm, the more questions arise, and the more intriguing it becomes. The challenges are many, but so are the possibilities. Quantum physics, in its essence, pushes the boundaries of what we believe is possible, constantly challenging us to reassess our understanding of the universe. So that's quantum physics for you. Intriguing, challenging, but also exciting. Well, that was quite a ride, wasn't it? We've delved into the fascinating world of quantum physics, unwrapped its basics, and explored its intriguing birth to revolution. We've seen how particles can behave like waves and how they can be in multiple places at the same time, a concept brought to life by the double slit experiment. We've taken a step back in time to understand the history of quantum physics, seeing how it has evolved and shaped our understanding of the universe. And we've also tackled the challenges that scientists face in this field, revealing how quantum physics pushes the boundaries of what we know and understand. It's been an enlightening journey, one that reminds us of the vastness of the universe and the mysteries it holds. Thank you for joining us on this quantum journey. Stay curious, keep exploring, and remember, science is fun with Bang with Science. Until next time, goodbye.